Okay, so you did pretty well with that. This is going to be e to the capital P of t prime times y plus e to the capital P of t y prime. Of course, the right-hand side, can't do anything with that until we know what the functions are. Okay? So you want to write it out step by step. You know, you had a question, a little confused. Do you write it out like this? Do you write it out like that? Basically, you do the simplest step first, and you do one simple step at a time when it looks unfamiliar. And then when you see it, you can start skipping steps if you're confident enough. And if your judgment of when you're confident is good, then you'd be okay. But don't push it. Okay, take it as simple as possible until you're really sure you've got it. That reinforces it, etc. Well, what's e to the p of t prime? E to the p of t is a composite function, so the derivative is p prime of t, e to the p of t, where this is capital P times y, plus e to the capital P of t, y prime, equals capital P of t, g of t. Now, this little p of t looks a lot like the big P of t, so I'm just going to kind of make the little p of t script fancy, okay? And that's the only time it occurs up here, I think. Hopefully I've got it, okay? So that's almost like a G. It's a bad-looking P, but I want to distinguish it from the capital P just for right now. And when you write it, make sure you write it. Another way to do that is put two stems on the capital P, the double stem, okay? So what's big P prime of T?
Little p.
Okay, so this is our little p of t. Let's see if I can write that for you. No, it's hard to. That's our little p of t. E to the capital P of t, y, plus e to the capital P of t, y prime. Right? And this is just this, although I've got it in the opposite order, just because of the way we naturally write this out and the way we do the product rule, the order in which we usually do the product rule. It came out in reverse order, but obviously we can reverse that by the commutative property of addition. Okay? Make sense? So what we've done is we've changed this equation to this equation. Okay? Well, let's just say, okay, just to cut through all the details now. And now the P and the G almost look the same, so I gotta be careful. Okay? That might not have been the best notation I could have used, but becomes or is equivalent to e to the capital P of t, y prime equals, I almost did it again, e to the capital P of t, g of t. Okay? Which means that e to the capital P of t, y is an antiderivative of e to the P of t, g of t, with respect to t, right? Because if the derivative of something equals something, then the something is the integral of the other something. Too many somethings in that course, but you know I was pointing, so you should understand what I mean. Okay? So, for example, y prime plus ty equals cosine of t. Okay? So, little p of t is just t, because little p of t is whatever's in front of y. When you have just a 1 in front of your y prime and your g of t function's over here. Okay? So what are you going to use for big P of t? T squared over 2. Now if you wanted to add a constant, because any antiderivative will do, you'd have a t squared over 2 plus 793. That's exactly what you're probably thinking you wanted to use, but you knew, well, let's just keep it simple, t squared over 2, right? Okay? Yeah, the simplest antiderivative is generally the best one to use. If you use a different one, if you add a constant to it, it just makes it, you got a couple of extra algebra steps if you're going to solve for y. Okay? That's all. And sometimes that's enough. Okay, so P of t is this. So now, integrating factor is e to the t squared over 2. And by an integrating factor, we mean something we can multiply by the equation to put it in the form derivative of some mess equals something else. Okay? So, we multiply by the integrating factor. So we get e to the t squared over 2 y prime plus e to the t squared over 2 times t y equals e to the t squared over 2 times the cosine of t. And you should verify for yourself that this is then just e to the t squared over 2y prime equals e to the t squared over 2 cosine t, right? And now since the derivative equals this, all you have to do is integrate both sides and you get e to the t squared over 2y is general antiderivative of e to the t squared over 2 cosine of t dt. Okay? Now to integrate that, you have to use repeated integration by parts, which you need to review. Something you should have done a lot of, probably did, because you both had good courses. But you can't go any further until you know how to integrate that, and I'm not going to teach you how to integrate that. I'm going to tell you that by Tuesday you should be able to integrate that, plus a bunch of other stuff. Okay? And I'm going to give you several of these. I could have an e to the t or an e to the 5t. I could have any sine, cosine, or exponential function on the right-hand side, and you'd be able to integrate this. Okay? Maybe. Actually, maybe not. Anyhow, see if you can. Okay? If it was just t squared over 2 cosine t, it'd be easy. With the e to the t squared over 2, actually I'm thinking about it, and you know, that t that you get out of the chain rule is going to really mess things up, so I'd have to play with that to see if it can actually be integrated. I'll be sure to give you some you can integrate. And, you know, see if you can integrate that. But review integration by parts, especially things like t cosine of t or t squared e to the t, okay? Those kind of things. Now, put that in your homework. You're going to need to review those things. Once you've done this, if you can integrate this, which is not always guaranteed, matter of fact, usually you can't, okay? Not sure you can integrate this one, okay? But then your y is just going to be whatever you get divided by e to the t squared over 2. And you have to remember that when you integrate this, you do have to include the integration constant. Okay? So those are little details. But right now we're trying to get a view of the span of differential equations, you know, just kind of feeling for the main ideas. And get rid of the rust from your calculus course. So that's another bit of rust, integration. And you end up with doing a lot of integration by parts, and substitution obviously is almost every integral involves substitution or something worse. Okay? Even trig substitutions. But integration by parts, repeated integration by parts. Okay? So you got to have those techniques. So get those out of the way. You're doing real well with what I've seen so far. Everything I've seen looks pretty good. Haven't looked at all the details of what you gave me today, but seems like you're doing okay.